So bit means is a binary digits, that is zeros and ones. So we have only 2 digits. They have not mentioned any numbers. They have mentioned the word 3 uppercase and English letters followed by 3 digits. Single uppercase letter or an uppercase letter followed by a digit. It is very simple concept. A boy lives at X and wants to go to school at Z. So it is a starting point and he has to reach to destination called Z. Hello everybody, I am Shweta, Computer Science faculty, Vidhyaashram First Grade College, MYSURU. In my previous session, I have started counting concept and have explained some basic concepts on counting. So today I will explain the problems on counting. So counting is a process of understanding the number of possible outcomes in a series of events. In counting, we have studied product rule and sum rule, right? So I have discussed the basic problems on product rule and sum rules. Today I will explain the problems. So today I will explain the important problems on counting. So here the first problem, how many bit string of length 7 are there? How many bit strings of length 7 are there? Bits means it's a binary digits value zeros and ones, right? We have only 2 binary digits, that is 0 and 1. 0 and 1s are called as bits. 1 byte is equal to 8 bits. I hope you know about this concept, right? You have studied this in digital electronics. So bit means is a binary digits, that is zeros and ones. So we have only 2 digits. So here, how many bit strings of length 7 are there? How many bit strings of length 7 are there? So since each bit of digits 0 and 1, since apply the product rule, so how many bit strings of length 7 are there? So here from 0 to 7, 1, 2, 3, 4, 5, 6, 7. From 0 to 7, how many bit strings of length 7 are there? There are 2 bits, that is 0 and 1. So 2 power 7 is equal to 128. So 128 ways bit strings of length 7 are there. So 128 is a final answer. 2 power 7 is equal to 128. So then how many bit strings of length 6 are there? So 2 power 6. 2 power 6 is equal to 64. How many bit strings of length 3 are there? So 2 power 3 is equal to 8. So this type of question you can expect for 2 marks. Next problem. How many different car license plates can be made if each plate contains a sequence of 3 uppercase and English letters followed by 3 digits? So listen carefully. So here they have not mentioned any numbers. They have mentioned the word 3 uppercase and English letters followed by 3 digits. So in English alphabet we have 26 letters, right? We have 26 letters and in question they have mentioned how many different car license plates can be made if each plate contains sequence of 3 uppercase. 3 uppercase means 26, 26, 26 followed by 3 digit. So 3 uppercase followed by 3 digits. So totally we have 0 to 9 digits, right? 0 to 9 means we have totally 10 digits. So English letters followed by English letters means 26 letters, 26 letters, 26 letters. That means 3 uppercase. They have mentioned it is 3 uppercase and it is followed by 3 digits. 3 digits means 10 into 10 into 10. So just multiply this, you will get the final answer. I'll repeat. Here they have not mentioned the numbers. How many different car license plates can be made if each plate contains sequence of 3 uppercase? In English alphabet, we have 26 letters, right? So 3 uppercase means we have to repeat 3 times, 3 uppercase, and English letters, these are the English letters, 3 uppercase followed by 3 digits, 10, 10, 10. In digits, we have 0 to 9 digits, that is totally 10 digits, that is 10 into 10 into 10. So multiply these terms, you can use calculator, normal calculator, and you can find the final answer. So total answer is 17,576,000. This is the final answer. Here we are applying the counting method. Here we are applying the product rule. You just multiply all the uppercase letters and 3 digits. So you will get 17,576,000. So this is the final answer. So next problem. Suppose variable names in a programming language can be either a single uppercase. So totally we have 26 letters in alphabet. Single uppercase letter, or we have OR symbol. OR means logically we are using addition, right? In OR operation we are using addition, right? So OR means addition, or an uppercase followed by, again uppercase followed by digit. Clear? So here I'll repeat, single uppercase, this is single uppercase, or an uppercase followed by a digit. So first multiply this and add this, you will get the final answer. So 26 plus 26 into 10 is 260. So we will get 286. The final answer is 286 ways we can arrange the letters and digits. So single uppercase letter or an uppercase letter followed by a digit. It is very simple concept. Next question. A boy lives at X and wants to go to school at Z. Listen carefully. A boy lives at X and wants to go to school at Z. And from his home, this is the location of home. From his home X, he has to first reach to Y and then Y to Z. First he has to reach to Y, then Y to Z. He may go to X to Y by either 2 bus route or means it is plus, and 2 train routes. I'll repeat. From his home X to, he has to first reach to Y and then to Z. He may go to X to Y by either 2 bus routes or 2 train routes. So 2 plus 2, he can reach by 2 bus route plus 2 train routes. So 4 possible ways. So 4 ways he can reach from X to Y. And from there means from here, he can either choose 4 bus routes or means plus 5 train routes. So totally 9 ways he can reach from Y to Z. I'll repeat. From X to Y, either he can choose 2 bus route or 2 train route. Or means addition. So 2 plus 2, 4 ways he can reach from X to Y. And from there means from here, he can reach to Y by 4 bus route plus 5 train routes. So totally 9 ways he can travel. Then what is the question? How many ways are there to go from X to Z? How many ways are there from X to Z? From X to Z means here we have 4 ways from X to Y, and from Y to Z he has 9 ways. So totally 36 ways are there. So 36 ways are there from X to Z. To reach from X to Z, 36 ways are there. So it is very simple concept. I'll repeat again. A boy lives at X and wants to go to school at Z. So it is a starting point and he has to reach to destination called Z. And from his home means X, he has to first reach to Y and then Y to Z. he may go to X to Y by 2 routes called 2 bus route plus 2 train routes. So totally he can choose 4 ways to travel from X to Y. And from there means from Y, either he can choose 4 bus or 5 train. So totally 9 ways he can travel from Y to Z. So now the question is, how many ways are there to go from X to Z? So how many ways are there from X to Z? So totally 4 ways from X to Y and 9 ways from Y to Z. So totally 36 ways are there to reach from X to Z. So this is called as counting. So we have to understand the logic properly. So easily you can solve this problem. The next problem is, there are 10 true-false questions. So there are 10 true-false questions. True-false means how many type of questions are there? 2 type of questions. So one is true conditions or another one is false questions. So true questions and false questions. So totally we have 2 types of questions. So totally we have 2 types of questions and 10 true false conditions are there. So we have 2 types of questions, that is true or false. So totally 2 types of questions, right? In how many different ways questions can be marked? So we have 2 types of questions, true or false. Then totally there are 10 true false conditions. There are 10 true questions are there. So how many ways, different ways questions can be marked? So 2 into 2 into 2 into 2, 2, 10 times you have to write 2, 3, 6, 9 and 10. So totally 3, 6, 9 and 10. So totally 10 true false questions are there. So how many different ways questions can be marked? So 2 power 1, 1, 1. So 10 true false questions means we can arrange like this. Next, add all the exponentials value because all the base values are same. So you can add all the exponential value. So it is 2 power 10. You will get 2 power 10. So 2 power 1 plus 1 plus 1 plus 1 plus 1. So up to 10. So we have 10 different questions. But we have 10 questions, true false questions. So we can arrange 2 power 10 ways. So what is the value of 2 power 10? This 1024 possibilities are there. So 1024 possibilities are there to arrange the questions called true and false type of questions. You can arrange like this. So every step you have to write in exams, then only you can score. So this type of questions you can expect for 4 marks or 2 marks. So today you learned some problems on counting. So it is very important question. Easily you can solve this problem. Please understand the logic. So in my next session, I will come with a new concept in counting, that is pigeonhole principle. It is very important concept. Thank you.